My name is Burt Beckwith. I am a Micronaut developer at Oracle. And I am going to be talking today about Micronaut security. So let's get started. So here's some contact information. If you have questions later, email, Twitter, my GitHub repos. Yeah, so before we talk about Micronaut security, I think we need to talk a little bit about Micronaut. I'm sure that some of you are somewhat new to it. So Micronaut is about 3 years old at this point, started around 2018. We are in the process of doing the release for version 3.1 today, tomorrow-ish. So it's been around a while. Had a few revs and some changes. Initially, it was really heavily focused on microservices. And of course, that is still a very big focus. But in the version 2 and version 3, much more functionality has been added. For example, in the initial versions of Micronaut, there really wasn't any support for rendering views, right? Because it was assumed that microservices would talk to each other through JSON payloads and stuff. But of course, lots of view technologies have been added. So really a full-featured framework at this point. But it is quite different from other frameworks you may have used, in particular Spring Boot. Spring Boot is the elephant in the room, right? So the big thing about Micronaut that makes it compelling versus other frameworks is that it does a tremendous amount of the work at compile time instead of at runtime. And that's important and has some really interesting benefits in terms of application performance, memory usage, important ideas for any sort of an application. So the way that works is that there's an annotation processor. So Micronaut is heavily based off of annotations. So compile time, we're going to build up proxies for security proxies or AOT proxies. We're going to figure out a whole bunch of information about what are the beans, what are their properties. We're even going to do stuff like introspect data classes, like POJOs, that are going to be used to render JSON, right? And in order to do that, using Jackson, the default is to use reflection to find, based on like when you deserialize, right? You've got a name property and an age property. So that means that in order to serialize that into an object, you've got to call set name and set age. So you've got to reflectively look in and find those methods. And that can be a little expensive at runtime, and reflection, gets better and better every JDK release. But if we can do all that work ahead of time so that the information is pre-cached, then startup is going to be really fast and memory usage is going to be really light. And one other huge benefit of this approach is that we work really, really well with Auth Vm, in particular with native image, which if you're not familiar with it, I highly recommend you Google it. I'm not going to spend a whole bunch of time on that because it's not really relevant to security, but it's a open JDK released by Oracle Labs, and in JIT mode, it is fully compliant. It's just like any other JDK. You can just swap in your open JDK for Auth Vm and immediately see 10-20% performance improvement and reduced memory usage. But then you can further compile your application into a native binary. It's platform specific, so you can create a Windows binary, a Linux binary, whatever. And that will start up insanely quickly. We've got it down to under 10 milliseconds in some test apps, and much highly reduced memory usage. So it's really great for cloud deployments and functions, because if you don't need to start up a huge JVM just to have some, to do one small thing, that having that focused performance is really great. So do check out Auth Vm. Very cool stuff. Very, very, very neat stuff. All right, so Micronaut security. It's coincidentally the same version as the current Micronaut version, but it's not coupled at all. So it's version separately. So 3.0 was released today. The source repo is there. Documentation is pretty extensive. I recommend you check that out. And one thing that we do that a lot of other frameworks do is we have a bunch of tutorials and guides online that lead you through the process of doing various tasks, you know, doing database access, doing security, distributed configuration, all kinds of cool stuff. So do check out those guides. There's, I think, 12 different security guides and over 50 total. So really good stuff. I've written a few of those, and they're pretty helpful for getting you up to speed quickly on the basics of Micronaut and then some more intermediate and advanced concepts. I did want to talk briefly about Spring Security versus Micronaut Security, because this is something that I faced. I'm somewhat new to Micronaut, so like a lot of you, you probably have used Spring Boot quite a bit, and probably Spring Security. And at a high level, you know, Micronaut Security does all the cool stuff that you expect from any security support, right? But it is really, really fundamentally different from Spring Security. So under the hood, at least, you know, as far as a user, it's fairly similar for user code. But the way that things are implemented under the hood is quite different, in a very good way. It's highly reactive. Almost everything is reactive, so everything has a callback. Everything returns a publisher, so that we can do work on you know, stop doing work on the event loop, which is, you know, processing requests, and offload work that could be potentially expensive, like making a remote call to an external authentication provider for OAuth, or if you're hitting a database to try to find a user, see if a user's there, you know, validate the password or whatever. You know, most database calls are blocking unless you're using something new like R2DBC. So we don't want to slow down performance of the entire application just because, you know, our users are logging in. So really, so that can be a bit of a can kind of mess with your head a little bit if you're used to if you're very used to Spring Security like I am. So creating applications in Micronaut, I'm going to be doing some demos, so I'll show you a few different ways of creating these. But we have a website, micronaut.io/launch, and that's a really great way of creating applications. You can create applications, messaging apps for using Kafka, function apps for deployment into Oracle Cloud or AWS or Azure or whatever. And you can choose different features. You can use Java, Groovy, or Kotlin. You can use Gradle or Maven. Please use Gradle. And we also have different options for testing frameworks. And I'll show you this in a bit. If you click the features link, then you get a whole gigantic list of cool things that you can add in to extend your application with functionality. If you like using the command line, there is a command line available that you can. The easiest way to install it is using SDKman, which if you're not familiar with SDKman, please check that out because it's amazing. It'll install JDKs, it'll install Auth Vm, it'll install Grails, Groovy, Micronaut, Gradle, and it's a huge list of stuff that it'll work with is huge and getting longer all the time. And one interesting thing, so let me go back here. So once you pick all your features, if you click the diff button, it'll show you what is different about the current configuration that it's going to build the application from versus a default application. So that can be really handy to find out because you know, if you want to add some functionality to your application, you're not going to create a whole new app, right? You're going to, you want to add in the dependencies and the configuration to add in whatever the security or distributed configuration or database connectivity or whatever. So using that diff button is really great for knowing just what files to tweak to augment an existing application. So a really nice feature. And here's a quick example. So I chose security JWT. So by default, the annotation dependency is added, and we'll talk about that in a bit. And the security JWT, and there's support for, obviously not just JWT, there's others, other authentication approaches. And in addition, these features can contribute whole files, or they can contribute additional configuration to your application YAML. So do check that out. So there's a bunch of different authentication strategies. So HTTP basic auth is enabled by default, and you can disable it, of course. Session-based authorization is supported, so that uses cookies, and that's typically is implemented with form-based logins. So that's what a website that with user interaction probably might use. And of course, JWT and OAuth, LDAP, and then it's pretty straightforward to create your own implementations. There's an example of using X.509 browser certificates to use for validating that users have various permissions or that they're authenticated. So annotation. So like I said, Micronaut is heavily annotation based. So, and Micronaut security is the same way. So you don't have to use annotations. There are multiple ways that you can configure the security rules for what URLs are guarded and what roles or what rules really are required to access those endpoints. But @secured annotation is a nice convenient way to do that. So we have support for @secured, which is our own annotation. And then we also support the JSR 250 annotations. And the old ones are still supported, the Java X, but we've recently switched to the newest version of Jakarta JDE. So everything, we've switched from Java X to Jakarta. Like for the @singleton and @inject and all those. So they're all supported. And the way that that's implemented is really kind of interesting. I'm not going to spend a lot of time on this, but those are implemented as annotation mappers. So again, because we are parsing your source code to build metadata about how to run your application, we can see that you're using the Jakarta permit all, and we're going to convert that to the equivalent in Micronaut. So the metadata, the rule. So we don't really process the JSR 250 annotations. We pre-process them, and then it's as if you had used Micronaut functionality the whole time. So this is part of a larger concept of security rules. So one type is the @secured and JSR 250. So here's some examples of using that. So these are equivalent. There isn't really a JSR 250 for this. Just says that there's no particular role that's required. It's just that in order to access this endpoint, this controller, this whatever, you just have to be logged in. You have to have previously authenticated. Is anonymous means anyone can access it. So whether you're authenticated or not, you can access that. That's permit all. And then denial is of course supported. And that's kind of a weird one. I had to actually Google them. So I was wondering why would you ever use denial? And the answer that I sort of found is that that's for something like if you have say a public method that is callable, but it's, for example, because of you're implementing an interface or something, but it's not really something you would call externally. You can say deny all access to this. So you can call it from within the application. You just can't call it from outside of the application. There's also IP pattern rules that you can apply. So you can restrict access to one thing I did using the similar functionalities for security years ago was we had an admin subset of pages that were admin pages, and you had to come from a 10 IP address, meaning you had to either be in the office or on the VPN. And if you didn't have that, if you didn't satisfy that IP requirement, then you'd get bounced. And then in addition to specifying rules with annotations, you can specify it as a big URL map. So that would be in your configuration, that would be in your application YAML. And that's really ideal for, well, I think there's two big use cases for that. One is static resources. So if, for example, you wanted to have some, again, like an admin JavaScript, admin images or whatever, you can block access to those unless certain security rules are satisfied. And another thing that can be important is, by default, everything once you enable security, everything is locked down by default, and you have to enable it. You have to open it up with a @secured rule or a URL map. So your favcon.ico is going to get blocked. Your images are going to get blocked. CSS, JavaScript, that's all going to get blocked unless you open it up. So so you can't annotate those. Obviously, that doesn't make sense. So you can do that in the configuration. And another thing that you can do is if you had some classes, say controller classes in a jar file that aren't annotated, but you want to add security logic to those, you can specify those URL patterns because you can't actually edit the source code. So that's pretty convenient. And you can mix and match. You can use some secured, some annotations, and some URL map stuff. So the core of the implementation is this class called the security filter. So it's enabled by default, and that's why as soon as you add in any security dependencies to your application, the filter is going to be active. It's going to be added to, it's going to be added in with all the filters that Micronaut has. And there's an order, right? So security happens pretty early on. And the way that it works is that as a request comes in, it's going to first hit that authentication fetcher layer. So that's going to try to see, are you already authenticated, right? So in various ways you can do that. You can see if there's a session ID. Are you using session-based authentication? So is there a session, an authentication stored in the session? Or if you're using basic auth, it'll do the basic auth stuff. And for stuff like OAuth and JWT, it'll look for a bearer token or however you're sending in your access token, either with a cookie or with a header, and it'll determine that you're already authenticated and so you're good, or it'll bounce you back to a login page or whatever you do to like in basic auth, you send the www-authenticate header, and in a browser it pops up that dialog. So for the token, the big there's a ton of code in Micronaut security for JWT and OAuth. So that section, the token resolver, token validator, that isn't done. That's only done really for token-based auth. But there's various token readers and validators, layers of those. And then, so once all that's checked, then you hit the security rules, which is the @secured, the URL maps. There's also one for the endpoint security. So there's a bunch of management endpoints you can call to get bean information or logger information or set your loggers. So those can be guarded. And you can create your own security rules by implementing the security rule interface and registering that as a singleton. And Micronaut will find all of those beans and they can be ordered. So it'll loop through all of them that it finds, and it'll make a decision on whether or not you should be allowed to go forward. So, and really quickly, the logic basically is that if anyone denies, then you're bounced. You have to have at least one that allows access. So if no one, so there's three, the security rule can return one of three answers: yes, no, or I don't know. So if everyone says I don't know, then you're bounced because no one said yes. So if at least one says yes and no one says no, then you're good. If one says no, then you're bounced. And then one quick thing, if the only one that says yes is the IP address rule, then that's not enough because that's sort of a secondary check, right? So you still have to have a role or a URL map or something that allows access. So there's a concept of the authentication provider. And really what this is basically the thing that checks to see, is the user valid? Does the user exist? Is the password valid? Are they an active user? Have they not been locked out? Have they not been disabled? That sort of logic. So for the most part, that's something that you implement yourself. There are a few implementations that come with Micronaut. One is for LDAP, because that's fairly complex, and so we do a lot of the logic for using the LDAP APIs to go over to your LDAP server or servers, because you can have more than one, and so it'll do that logic of checking to see if the user exists, checking if the password makes sense, getting the groups, and then inferring those groups to be roles, and then you can of course customize that and add in a role underscore prefix or something like that. And then for OAuth and OpenID Connect for the password grant flow, there's also one for that. But for everything else, you have to, or get to, depending on your attitude, get to implement the authentication provider yourself. So we'll see in the demos a very trivial, silly example, but it's you can do you can do whatever you need to do. Go to the database, do bcrypt password hashing checks, all that standard sort of stuff that you would do. Events. So Micronaut has support for application events, and so there's tons of them being fired all the time. So when the application starts up, there's a started event. When it shuts down, there's a shutdown event. Tons and tons of events along the way, and then there are security specific events, 6 of them that may or may not be sent while you're in your application. So we'll see some examples of those. So those are good for logging or just keeping a record of various things that happen. So you can, write that event information to, some sort of a logging stream or to a database or however you want to, track stuff. All right, so that's the big points. But I think rather than just blathering on for 50 minutes, I think it'll be good to do some demos. So let me switch to IntelliJ and let me create some applications. So the first one, really quickly, let me do a quick demo of this because I showed you the screenshots. But so let's say I add in security-JWT. So this is that diff that I was showing, and then and this is Gradle, of course. If you use Maven, friends don't let friends use Maven, but if you must, then you'll see the diff there. It'll be an XML diff instead of a Gradle diff. But this is what I was talking about, where you can edit your files to add in the stuff that's added by those various features. So, and one really cool thing, you can download a zip file, unpack that, and you've got an application ready to go. I use this all the time because I always forget all the flags and stuff. So I'll come in here and I'll build it up, and then I'll copy this and run it from the command line. And of course, we also support, you can make curl requests to the website, and it'll send you a zip file. So you could use that for CI or all sorts of different things. And then one really cool thing is you can push to GitHub, and it'll do an OAuth login, and if everything is cool, then it'll actually upload, create a repository with that application right into your GitHub account, which is pretty slick. So what I'm going to do is I'm going to create these inside of IntelliJ because it's super convenient. And if you note that it actually uses, this is just a front end. This wizard is just a front end for the launch.micronaut.io. So you'll see the it's always in sync. All right, so this first one is going to be basic. And for this one, all I need is the core security. There's no basic thing because it comes as a part of Micronaut security. And one other really important thing is I need a reactive implementation because, like I said, almost everything in Micronaut security is reactive. So we don't require that you use Reactor or RxJava. Everything is very generic and interface based. But we strongly recommend that you use Reactive. That's what we're using everywhere. We've kind of standardized on that as the best implementation, best reactive implementation, actively developed and lots of cool features, functionality. All right, so that's going to create this application. And so what did we get? Let's take a quick look at the build.gradle. Just like we saw in the diff, you've got the security annotations in the annotation processor scope. And if you use Maven, we do the equivalent for Maven. So you can do that there. And then here's the Reactor stuff that was added. And there's nothing special right in the config because, like I said, there's really not much to do with basic auth. So let's create a controller that we will secure. Okay, so this is a standard Micronaut controller, and so it's annotated as that controller. This does a few things. It registers the bean as a singleton by default. It registers it as a bean. So the default scope is singleton. And it's got a handful of properties that you can configure. So the big ones are the URI, the root URI for the controller. And then if you want to, you can, by default, we consume and produce JSON. But of course, you can override that either or both. And you can also do that at the method level with those annotations. So here's the @secured. And we're saying that you have to be authenticated to call this method. This is a get. So the default URI for controller is /. And the default for get is also /. And you can see that the get also has produces and consumes. So the method name doesn't matter because what really matters is how you call it, and that's defined by the get annotation and the URI combination of controller and get. And this is an interesting feature. So you can dependency inject the principal, and this won't be null because it will require that you be authenticated. And the principal basically just has the name. So this is the username or whoever is interacting with the application. You can also dependency inject the authentication object, which is a little bit bigger, and that has roles, and it has a map of generic properties that you can set. So depending on the implementation, just a sort of a mixed bag of extra properties that may be useful. So for a method that, for example, it doesn't require that you be authenticated, you can say @nullable. And then you can check to see if it's null, and if that is the case, you would have to say like is null, right? And then you would check to see if it's null, and if it is null, then you're not logged in. If it isn't null, then you're logged in. Yada, yada, yada. All right, so that's a controller. We also need an authentication provider, like I mentioned on the slides. There is no authentication provider built into Micronaut security that makes sense for this use case. So we just have to create our own. And the implementation will be pretty silly, but it gets the ideas going. So let's take a quick look at this. So we implement the authentication provider interface and register it as a singleton, so it gets discovered. So security will auto discover all the authentication providers. It'll basically loop through them, and the first one to successfully authenticate will allow access, and if none of them allow access, then you get bounced. So again, you return a publisher so that this can be processed in a separate thread. And so basically, I delegate down here to an isValid method. So if you're valid, then we log a message and we succeed. And if it isn't valid, then we log a different message and we throw an exception. And we'll see an exception handler in a second because we actually need it for basic authentication. So the traditional thing would be to redirect to an error page, right? Or back to the login page. But that doesn't make sense for basic auth. So isValid would, in a non-trivial example like this one, would go to a database or go to somewhere else, right? And figure out, is the username valid? And given that username is valid, is the password valid for that user? In this case, we're just hard coding this silly one user, one password. And we'll reuse the same one throughout the different examples. So we need to replace the exception handler. And that will point out another interesting feature of Micronaut is replacing beans. So there is a default authorization exception handler, which implements exception handler for this type of exception, and it produces this sort of thing but that's the way that it handles the exception, right? So it's a singleton, so it's auto registered. So to replace it, you say @replaces. So Micronaut makes it really easy without having to. In this case, we're going to subclass, but you could completely re-implement the interface. You can do whatever you need to do, and the other bean won't be active, and this one will. So yours wins. So we're going to only, because most of the functionality we want to keep, and especially the the dependency injection stuff. All that we really need to worry about, because there's a lot of there's redirect logic and all that stuff. But for basic, we're not going to get redirected. All we're going to do is we're going to send a www-authenticate header. So all we need to do is override this method, and then there are two cases, right? So forbidden means, well, let's see what that means. It means that you're not logged in. So forbidden means authentication. Oh, no. So you are logged in, right? So if you throw an exception and you are logged in, then we send the forbidden error, which is 403, right? But if you're not logged in, then we send an unauthorized code, which is 401. And we set a header, the www-authenticate header, with a realm name. And that's what's going to get popped up in the browser. So that's how that's basically all you need to do to implement basic auth. So let's do one more controller that isn't just a sort of a hello world controller. It's not much more complex though, to be honest. But it's sort of an example of doing real work, not just echoing the username of the logged in person. So this is super silly. It just adds two numbers together. It adds any two numbers. So we got that going for you, including negative numbers. So of course, this is a trivial, silly example, but this is the sort of thing you'll do, right? So you'll use various secured annotations to restrict access. You define the URI patterns, and then you return this. So this is only callable if you're authenticated. All right. Now we can actually test this thing. So first step is get the app running. And then I'm going to use Firefox for this because you can't log out from a basic auth authentication, right? You have to close your browser, but I don't want to close my main browser. So I'm going to go to localhost 8080, and I'm sure you've seen this before, right? So this is the realm name that we specified. And if I specify junk, then it fails. But if I do the right thing, it works, and then it returns the username. So let's test this with curl, and I'm also going to create a little client application that will programmatically call this. So if we just curl localhost 8080, we do the -v so we can see all the headers. Then we can see that we got the 401 we're expecting, and we got the www authenticate header. So curl will use this to do the right thing. So, but of course, it can't create the authentication header, authorization header, because we didn't provide a username and password. But if we do, so -u for bar, and that's bad password, bad username, then it will send that in the authorization header. So this is, you're probably familiar with this. This is just a base 64 encoding of the username plus a colon plus the password. So it's not secure at all. You should always do this over SSL. So because it's not encrypted, it's just obscured. So it sent that, but it didn't work. We gave the wrong username and password. So if we do the right thing, increase the font on that so everyone can see. Now we got a 200 OK, and it responds with our username. And then just one more quick one. If we call that math API, same thing, we get a 200. And then we discover that 123 plus 456 is 579. That's pretty amazing to learn. All right, so having done that, let me create a quick little client application. Now this one doesn't actually need any dependencies because it's not going to actually use Micronaut security. going to use some very different functionality. So what we're going to do is we're going to create, well, first thing we want to do is set this up to run on a different port, because it will collide with the other one. We're going to run both apps at the same time. So in our configuration, we tweak this so that it runs on port 81 instead. And well, let's create a client. So this is a pretty cool thing. Very cool feature of Micronaut. This isn't a security related feature. This is a just a cool feature. So you can define API client or clients, HTTP clients to any endpoints, to internal endpoints or to another microservice in your cluster, in your deployment or whatever, or to a remote resource. So here we're saying that we're going to call over to the application that has to be running, and this you don't have to hard code this. This can come from a configuration. So, and Micronaut will create an actual class from this at compile time. And since this is compiled, this is already done. So if we look in the compile classes, we would see the implementation of this class because it's already done. And we say that we're going to get, so this uses the same annotations as a controller does. On a controller, it's a server side. On the client, it's client side, but we can use the same rules. So because the controller produces text plain, we need to consume text plain. So we can do that here. And the signature here is pretty much the same as that on the server. One big difference being we're going to send the authorization header. And so the way to do that is, well, there's a bunch of different ways to do that. So what we could do is we could create a controller that calls that client or something. There's a bunch of different ways that we could implement this. But what I'm going to do is just create an event listener for the startup event. Dependency inject the client, and then when the event fires, so this is a singleton bean. And then Micronaut's going to see that this method or multiple methods are annotated with event listener. The method name doesn't matter. We can call this foo, whatever we want to call it. What matters is the combination of the annotation and the event type. So what Micronaut is going to do is it's going to create a proxy for this method. And that's going to be registered as an event listener. That's going to receive the event. And then it's going to call into your method with that event. So you don't have to do all that wiring of all the crazy stuff you got to do. So we're going to just basically call the client method with 2 numbers, and then we're going to generate the auth header. So again, this would probably come from a config because you wouldn't want this hard coded like this. Or you might look it up dynamically, however you want to do that. And we're going to send in the authorization is basic space, and then that base 64. We saw that from the curl command. So we can just fire this right up, and we'll see in the output that when it starts, we learn the amazing fact that 1 + 2 = 3. So that succeeded. And then if we look over at the other app, I had all those print lines in there. So these are from playing with the in the browser, and then this is for which has happened from this client. So pretty cool stuff. All right, so let me do another quick one for session security. And this one's going to be a little bit different. So like for the first one, we're going to, instead of using just the Micronaut security, we're going to do Micronaut session, which also depends on this. So we'll get both of those. We need to pick a reactive implementation. So I'm going to choose a reactor again. And one other thing we'll need is, because this is form-based authentication, right? Session-based. So we need a view renderer to render a login page and that sort of stuff. So I'm going to use Velocity, but you can use any of these other front-end technologies that you like. And sorry, so again, we're going to create a there's one quick thing I need to do. And that is configure the redirects. So in my application YAML, I need to add in so I think this is the default value, but this is going to be important later because this is the URL that we're going to be using for the stuff we're going to be creating. So, all right, so we got that. Let's create a controller again. It's going to be a little bit different. So this one allows anonymous access because we need to be able to provide a login page for non-authenticated users. So again, it's the root URI, the root get, so it's just localhost 8080. We declare that this uses the home view, and we'll create that in a sec. And again, this method name isn't important. And this is the example, I was talking about this earlier. So we say, if we dependency inject this principal, so if it's null, then you're not logged in. And if it isn't null, then you are. And so we can do different things. And so this is basically the model, right? So model view controller is we're returning the model that's going to get rendered or worked with by the view layer. So we need to create that home view. So let's create a directory for that. That's views and home.vm. So if you haven't used Velocity before, I think it's pretty readable. It's mostly HTML with some markup inside. So it's it's got these if checks. So if logged in is true, and that was passed in, remember from the so we're gonna in this map that gets passed down, we're gonna pass in logged in is going to be Boolean, and then username is going to be either not null string or null. So if this is true, if we are logged in, then we show the username and we show a way to log out. Else, we say you're not logged in, and we show you the link to log in. All right, so and so we need to support this endpoint. So we'll do that with a login auth controller. Yeah, this is a controller /login/auth. So this combination, that's going to call this guy, and then this is that auth failed. So this is that thing right here. So when we get the failure, the exception handler is going to use our override to redirect to here so that we can re-render the login page and then say your authentication failed, please try again. So we return an empty model, modifiable, because the security implementation may add in attributes to this. So you can't just send a collections.empty map. And that's going to get used by the next page that we create, which is going to be Auth.vm. And we need that because we said that this is the view here is auth. So let's create that. And again, fairly standard stuff. So a different title based on whether you're logged in or not, whether you had an error or not, right? So if there were errors, authentication failed, so we say that. We render a login page, and we username, password, submit. And standard stuff, standard login page. And we need an authentication provider, like we always do, because, like I said, there aren't many that are actually implemented that make sense. So this is going to be the same cheesy thing that we did before, where we just have a hard-coded username and password. Same thing. Okay, so that is ready to run. And I'm going to use my main browser for that because I can't actually log out. So localhost 8080, you're not logged in. Click the login page and it takes us to the net controller method, then bounces us back to here. And if we send in junk, then it fails. And if we send in stuff, then it works. And my password manager wants me to save this silly password, which I'm not going to do. And now we can log out. Well, actually, let's peek at the, we have a session cookie and it shows us who we're logged in as, and then we can log out and do the whole thing again. So that's session auth. Let me do one more quick one because I think this is probably most appropriate for microservice type stuff. I'm not going to do OAuth because, you know, we need another couple hours to do OAuth. So let's do JWT, which is sort of OAuth light. It's very cool. Has a lot of the same functionality, but you know, it's not quite a full OAuth. It's not a protocol. It's just, you know, a token format. So we use Nimbus Jose as the library to do a lot of the work for us. You can send the token, a JWT token, as a header or as via a cookie, and we can, you know, with like any JWTs, you can sign and/or encrypt. We'll see examples of both. So for this, we need security JWT. We need reactive implementation, and that is all we need because there's not going to be any UI or anything like that. So again, if we look in the configuration, get some default stuff. So we set the authentication mode to bearer tokens, and then we can configure the JWT signature generation. So this is, you've probably seen the same sort of syntax in Spring Boot. It looks for a environment variable or system property with that name, and we can use this as a default. So it's a bad idea to do that. So we probably want to do this. But if you don't delete it, definitely change it to something that makes sense, something other than the default. So again, we need a controller. And we need do the same API controller as before. The authentication provider. Choose the one that we've been using all along. And it's also, because we haven't really seen it yet, create some security event listeners so we can see some examples of that. And I'll make this code available later on. And the slides also. So before in the other application, the basic auth client, we just had the one event listener. Here we have several. 6 of them, one for each of the security events that gets fired. So two that we definitely won't see are logout, because that doesn't make sense with JWT, and refresh token. Micronaut security has support for, obviously, for refresh tokens. That's a more advanced thing. You've got to implement persistence of some sort, because you got to store them and retrieve them. It's we definitely don't have time for that. But just so you have some examples. So the source of these events is typically the thing you want to look at, right? So it'll be different depending on what's going on. It's either the authentication or the token or whatever that is. So we can print those out, or log into a database, or whatever you want to do. So let's fire this guy up. Do some testing. It started. Just what we expect. If you just make the call, it'll fail. If we attempt to authenticate the bad username and password, we'll get a 401 unauthorized. But if we successfully authenticate, then cool things happen. So we get this is our JWT. So if you've worked with these before, you know that typically there's 2 dots, right? So this is the header, this is the payload, and then the third one is the signature. And that's optional. You don't always necessarily have a signature. And we'll switch to encryption in a bit, and we'll see how everything changes. So we've been given this, and so as a caller to the API, you need to keep that somewhere. I'm just going to keep the command line a little cleaner. I'm going to export that JWT, and then so I'm going to make a call to the API, the math API, and I'm going to send in the authorization header. So before we saw that curl was sending authentication : basic, and then the hash of the the base 64 hash of the username password. Here we're sending authorization bearer token, and we're going to send in the JWT as the token, and then that'll get validated with the server, and then unpacked, and we'll figure out what the claims are and all the cool stuff, so we can figure out what you're allowed to do. And that works. So we get a 200 OK, and we get the correct answer. And down here, if we look at the system out, we see the authentication failed, and this is in our authentication provider. We get a login failed event. Then we get the success, we get the login success event, we get a token generated, and we get a token validated. Right? So that all makes sense. And then really quickly, because we're running out of time, let's switch to encryption, or add in encryption, right? So it's do either or both. You can sign and encrypt, or just sign, or just encrypt, but obviously you should do, at least you should sign. And just FYI, so signing, everything's still clear text, but you add in a signature that you can verify. That's it says that this stuff came from someone you trust, hopefully. But with encryption, it makes the JWT completely opaque, and it needs to be decrypted. So you need to share a secret or share keys with. So we support shared secret, RSA, and elliptic curve. So tons and tons of different algorithms and encryption methods, and I really fell down a Wikipedia rat hole looking these up because there's a zillion of them, and some of them are deprecated, and some of them are great, and some a lot. You have to spend a lot of time kind of thinking about what's the best approach for your use cases. Some are better, but they're slower. Yada yada yada. Right. So that isn't really a Micronaut concept. It's not a Micronaut security concept. It's purely JWT. So that's you make that decision regardless of the server implementation. So if we stop this and restart, and then successfully authenticate again, I'm gonna log in with a good username password. Now we get a very different JWT. So if we count the dots, I think there's 5 of them, right? So this is the only thing you can unpack. So this is still up to the first dot, the header, right? So if we base64 decode this, we'll get the information that we need to know, the algorithm and the approach. So this can be then used with the shared secret or the shared keys can be used to decrypt the rest of the thing. But whether it's encrypted or not, we can do the same thing, right? We can reuse it, right? We don't care as a client what the token looks like, just that it's valid. So now if I make this call again with the new JWT, it works. Amazing. Okay, so we're almost out of time. That's everything. That's all the demo that I had. So we have a few minutes for questions. If people have any. And if not, that is totally okay. So I will give you a few minutes of your day back. I will tweet the. I need to push all this code up to GitHub and make the slides available. So I will watch my Twitter, and if you're interested in the code and the examples and stuff, I highly recommend you check out the Micronaut security documentation. It's very good. It's not complete. Most documentation, there's gaps in it, but it's very good. And I even more highly recommend you check out the guides. They're really, really good. I mean, I've written a few, so I'm not entirely you know, I didn't write any of the security ones, but Sergio and Ivan, they do great work. I've done most of the Oracle stuff because, you know, they work for Object Computing and I work for Oracle. But yeah, in fact, to be completely honest, because I am more of a Spring Security person than a Micronaut Security, I actually went through the guides that they wrote to learn some of the stuff for this presentation. So really, really good stuff. And there's a bunch on OAuth. So there's one for authenticating through LinkedIn, for GitHub, through Auth0. There's new ones in the pipeline. So really just tons and tons of information. And the guides are it's typically 6 different variants of the guide. So there's going to be, unless it doesn't make sense for the language, because some of them, because there's one guide on Kotlin extensions. So of course we don't have a Groovy version of that. That doesn't make sense. But most of the guides have Java, Groovy, and Kotlin code, and Gradle build instructions, and Maven build instructions. So if you use Maven, you know, you can just use that one instead, and it'll give you the XML you need. But the core of the guide is still, you know, the same, obviously. So question from Chris: is there something to consider regarding security when migrating from Micronaut 2? So absolutely. So a bunch of stuff changed in Micronaut Security 3. So there were some deprecations that were acted on, some signature changes. But for the most part, a lot of it is still the same. There was a concept of a user details class in older versions that is gone now. So now it's just authentication and a principal. So some things are simpler, some things have been made bigger, but there's upgrade notes in the documentation. So for package changes and class renames and things like that. And we have a getter. So if you go to I just noticed today that we have a link finally in our. So if we go to Micronaut launch, we have a link to our getter. I'm not going to click it because I think you'll be able to see discussions with the developers and stuff, the private stuff. But if you click this, it'll take you to our getter. And we got a bunch of different, we have a few different rooms where you can answer questions. It's fairly active. Got a lot of users asking a lot of really good questions. And it's nice because you get real-time support. And we got some folks in the US, we got some folks in Europe, so you can get an answer to your questions many hours of the day. So thanks for everything. Hope you enjoyed it, and hopefully talk to you soon.
Bye.